Look around you. Just look around you. Have you figured out what we're looking for? Yes, you've guessed it. Motion. Today we will be studying motion. We will explain the acceleration due to gravity and demonstrate Newton's 3 laws of motion. Copy that down in your copybooks. In this explanation, we will be talking about acceleration due to gravity with the use of 2 water balloons. Notice that the balloons are in a close relative position. This is because our scientists drop the balloons from different starting positions. But they are going to hit the target at the same time. This is because their acceleration is the same. The acceleration due to gravity is 9.8 meters per second squared. Copy that down. Our first demonstration will be of Newton's first law. Our test subject will be a police officer who is unaware to our demonstration. We have to lure the police officer to come to where we need him. Our scientist has been more than a good sport by agreeing to do this. As the two approach our destination, note that we have taken precautions in order to not injure the police officer. Our scientist is now preparing the rope that will trip the police officer. Newton's first law is properly shown here. Newton's first law states that an object in motion or at rest tends to stay in motion at rest unless acted on by an outside force. This is also called inertia. Notice how he continues to fall forward even after the rope has stopped him. Inertia is the resistance of an object to want to change state of motion. Unfortunately for our scientist, stealing an apple, as you all know, is punishable by death. Newton's second law talks about how much force is needed in order to move an object of a certain mass to a certain acceleration. Our scientist has very little difficulty moving this garbage can because the garbage can is a small mass, so it took a small amount of force in order to move it. This can be expressed through the equation force equals mass times acceleration. Our scientist has much difficulty moving an object of a much greater mass, but the object has no difficulty moving him. Newton's third law demonstrates equal action and reaction. This is going to be demonstrated through the bouncing of the bouncy ball. The scientist is preparing to drop the bouncy ball. Watch closely. The scientist is going to drop the ball and there will be a force downward. It bounces back up with a force upward. This is equal and opposite force. We are now going to demonstrate increasing the acceleration due to gravity from 9.8 meters per second squared to 500 meters per second squared. The scientist has missed the dropping target, and the force going downward is much greater, unfortunately for our scientist.